नमस्कार दोस्तों, मैं शिवानंद उपाध्याय आपका स्वागत करता हूं हमारे YouTube चैनल केमिस्ट्री एकेडमी फॉर आईआईटी जेईई एंड नीट। This is the 24th day of JEE Mains revision and today we are going to discuss part 4 of coordination complex। वीडियो शुरू करने से पहले मैं आपसे अनुरोध करूंगा कि यदि आपने हमारा चैनल सब्सक्राइब नहीं किया है तो प्लीज उसको सब्सक्राइब करें और वीडियो अगर आपको पसंद आता है तो उसको शेयर करें, उसको लाइक करें। तो चलिए शुरू करते हैं कोऑर्डिनेशन कंपाउंड पार्ट 4। तो हमने पहले के 3 वीडियोस में ये डिस्कस किया, पहले 3 पार्ट्स में ये डिस्कस किया कि वैलेंस बॉन्ड थ्योरी से हम क्या प्रेडिक्ट कर सकते हैं और उसकी लिमिटेशंस क्या हैं। फिर हमने ये डिस्कस किया कि क्रिस्टल फील्ड थ्योरी और उसके एप्लीकेशंस क्या हैं। नाउ लिगेंड फील्ड थ्योरी एंड मॉलिक्यूलर ऑर्बिटल थ्योरी हमारे सिलेबस में नहीं है और उसकी वजह से कहीं कहीं पे हमें या तो स्ट्रक्चर या ज्योमेट्री बताने में या मैग्नेटिक मूवमेंट बताने में दिक्कत होती है। तो इन बातों को ध्यान में रख के हम कुछ पॉइंट्स डिस्कस करने जा रहे हैं। विद द हेल्प ऑफ दोज पॉइंट्स वी आर एबल टू सॉल्व the questions in JEE Mains as well as advanced. Some important points regarding coordination compounds. The first point is at least one or at most two d orbitals are used in hybridization. The second point is inner d orbitals are always occupied by strong field ligands. The third is pair of electrons can be shifted in lower energy orbitals but never in higher energy orbitals in presence of strong field ligands, but a single electron can go in higher energy orbitals in presence of strong field ligand. So this point is important. We are going to use this point in many of our good examples. Fourth point, it is not necessary that strong field ligands always form inner d orbital complex. For inner d orbital complex, inner orbital should be vacant. Like here we are discussing that in NiNS3 6 times 2 plus, this we know that ammonia is a strong field ligand, but in case of nickel plus 2, electronic configuration is 3d8 and coordination number is 6, and we cannot send these 2 electrons to outermost orbit because we are saying that in presence of a strong field ligand 2 electrons can come from higher energy orbit to lower, but the vice versa cannot take place. So because of that, 1 electron can shift it but 2 electrons cannot shift, and because of that we cannot use inner d orbital, so we have to use the outer d orbital. So hybridization is sp3d2 and this complex is outer orbital complex. So it is not necessary that strong field ligand always form inner orbital complex. Depending upon the orbital available, it may possible sometimes that in case of weak field ligand we can form inner orbital complex, and sometimes in case of a strong field ligand we cannot form inner orbital complex. So we have to understand this. The fifth point is platinum plus 2, palladium plus 2 and gold plus 3 even in presence of weak field ligands form low spin complexes when coordination number is 4. So we have discussed in crystal field theory that crystal field splitting energy depends on the charge on the central metal atom. It depends on the series of the central metal atom. Like for 4d and 5d series central metal atoms, the splitting energy is more than that of 3d, and it also depends on the ligand. So here if we are saying that platinum, palladium and gold, they are of 5d series, and because of these the crystal field splitting energy is greater than pairing energy. So if the central atom is of 4d 5d series, then weak field ligands will behave like strong field ligands because crystal field splitting energy is greater than mean pairing energy. Point 6, platinum plus 4. So platinum plus 2 will exist in coordination number 4 and platinum plus 4 will exist in coordination number 6. So platinum plus 4 coordination number 6, weak field ligand will behave like a strong field ligands. 7th point, in case of chromium plus 2, manganese plus 2, iron plus 2 and cobalt plus 2, you can see here that the electronic configuration of chromium plus 2 will be 3d4. This is 3d4, this is 3d5, this is 3d6, and this is 3d7. From 4 to 7, ammonia will behave like a weak field ligand, right? So in plus 2 oxidation state, though it is a strong field ligand, but because of plus 2 oxidation state, we are saying that it will behave like a weak field ligand. In case of chromium plus 3, iron plus 3, and cobalt plus 3, due to higher charges than these, ammonia will behave like a strong field ligand. So again, this is a point which is related, that crystal field splitting energy will depend on the charge or oxidation number of central metal atom. More will be the oxidation number or charge on central metal atom, more will be the crystal field splitting energy. 8th point, in case of cobalt plus 3 up to F minus ligand in octahedral complex, crystal field splitting energy is less than mean pairing energy. So here in NCERT, we have taken this spectrochemical series from NCERT, which is sufficient to solve the questions of mains and advanced. So different books have a long series. We are not following it. It is enough to follow NCERT. So in NCERT, whatever the series has been given, in general, we should remember that halogens are there, then oxygen family is there, then nitrogen family and carbon family. At the right hand side, and you can see here Cn minus CO, this is carbon family. Before that, nitrogen family, right? And there is mixing, of course, but in general we can say that weak field ligands में क्या आएंगे, halogens आएंगे, oxygen family वाले आएंगे. Strong field ligands में generally nitrogen और carbon family वाले आएंगे. बट स्ट्रॉन्ग फील्ड लिगेंड और वीक फील्ड लिगेंड केवल यही नहीं डिसाइड करते हैं कि स्प्लिटिंग एनर्जी इज ग्रेटर देन मीन पेयरिंग एनर्जी और वाइस वर्सा. अदर फैक्टर्स आर आल्सो देयर. So now you can see here that I minus, Br minus, Cl minus, F minus, यहाँ तक हम डिस्कस कर रहे हैं कि कोबाल्ट अगर +3 ऑक्सीडेशन स्टेट में अप टू F minus, the ligands will behave like weak field ligands, and we can say that crystal field splitting energy will less than pairing energy. But after F minus, because these two examples are from NCERT, water जो है वो यहाँ पे है और ऑक्सलेट आयन जस्ट उससे पहले है, और यूजुअली ये वीक फील्ड लिगेंड ही होते हैं. बट बिकॉज ऑफ कोबाल्ट +3, दे आर बिहेविंग लाइक अ स्ट्रॉन्ग फील्ड लिगेंड. So when they will behave like a strong field ligand, means delta naught is greater than splitting energy, then what will happen, 3d6 electronic configuration will be there in cobalt +6. So all the 6 electrons will go to T2G. We know that in case of octahedral complex there is a splitting, and the splitting is 3 orbitals below, which is known as T2G, and 2 orbitals above, which is known as EG. So when 6 electrons are there and delta naught is greater than pairing energy, definitely all the electrons will be paired. So the substance will be diamagnetic. Or if we want to write the hybridization, we can write the electronic configuration like this. And now we pair the electrons. So 2 inner d orbitals are vacant. So we'll say that hybridization will be D2sp3. Inner orbital complex will form. So in case of cobalt +3 with water and oxalate ion, inner orbital complex or low spin complex will be formed. Again, I will mention here that inner orbital complex word is related to valence bond theory, and low spin complex is related to magnetic moment, which is related to crystal field theory. Magnetic properties are explained by crystal field theory, while that geometry property will explained by valence bond theory. But the demerits are there, like we should know the magnetic moment before predicting the geometry. So now we are trying to solve those problems with the help of some points. The 9th point is, for coordination number 6, if electronic configuration is D1, D2, D3, then even in presence of weak field ligand, inner orbital complex will form. That seems to be very logical. Like if only 1, 2, 3 electrons are there, means the next 2 d orbitals of 3d are vacant. So we can use those d orbitals, right? So either it is weak field, then also they will form inner orbital complex. And there is no meaning of low spin or high spin in this case. because there is no pairing, right? So either it is weak field ligand or a strong field ligand, the magnetic moment is not going to change. Now, based on these 9 points, we are trying to solve some questions. Like first example is find the hybridization and magnetic moment of following complexes. So the first complex is CrNs3 6 times. We know that coordination number is 6. Chromium in +3 oxidation state. Chromium has an electronic configuration of 3d5 4s1. So in +3, it has an electronic configuration of 3d3 4s0. Now there are only 3 electrons in this 3d atomic orbital of chromium. 2 orbitals are vacant and coordination number is 6. So these will form inner orbital complex. The unpaired electrons here is 3 and magnetic moment is equal to, this is because of spin only. There are two types of magnetic moment: orbital magnetic moment and spin magnetic moment. Usually in case of transition element, the orbital magnetic moment will cancel out. So here, when we are writing magnetic moment in case of transition element, we are writing only spin magnetic moment. So the formula is under root n plus 2 Bose magnetron, where n is the number of unpaired electrons. So in this case, the number of unpaired electrons are 3. So 3 into 3 plus 2, that is 15, under root 15 Bose magnetron. An easy way to write this approximately, that whatever the number of unpaired electrons are there, if you add 0.7 or 0.8, roughly you will get the value of magnetic moment. This trick will be always valid, right? So this is about CrNs3 6 times. It is having a magnetic moment of approximately 3.7, and it has D2sp3 hybridization, means inner orbital complex. Here there is no meaning of low spin or high spin. Whatever the number of unpaired electrons are not going to change. If there are two situations where in case of weak field ligand unpaired electrons are more, and in case of a strong field ligand unpaired electrons are less, then there is a meaning to say the low spin complex or high spin complex. In case of D1, D2, D3, there is no meaning. Let us discuss the second question. COF63 minus. So here cobalt is present in +3 oxidation state. Cobalt means 3d74s2. So when it is present in +3 oxidation state, its electronic configuration is 3d64s0. Fluorine is a weak field ligand, right? We have written the point also up to fluorine. In case of cobalt +3, it will behave like a weak field ligand. So delta naught is less than its mean pairing energy, and if we see here that 6 electrons are there, will fill these 6 electrons, octahedral complex will form, right? So in this case, we have to use outer d orbital. So this is 4s, 4p and 4d, right? This was 3d. So outer orbital complex will form, and it is high spin complex because suppose here reverse is there. If delta naught is greater than pairing energy, then number of unpaired electrons will be 0. But here delta naught is less than pairing energy. So the number of unpaired electrons is equal to 4. If it is 4, then approximately we can say that spin magnetic moment is nearby 4.7 or 4.8. So hybridization is sp3d2. Next example is K4FeCN6. So we have written this as FeCN6 4 minus. We are discussing about this complex anion. So iron is present in +2 oxidation state. Electronic configuration for iron is 3d64s2. If we remove 2 electrons, we are getting 3d64s0. And Cn minus, you can see that Cn carbon family is a strong field ligand. So Cn minus is coming from carbon family, strong field ligand. So here we can say that delta naught is greater than mean pairing energy. If delta naught is greater than mean pairing energy, then we'll pair all these electrons. 6 electrons are there. So there are 2 vacant d orbitals. So we'll say that D2sp3 hybridization will be there. Magnetic moment will be 0 Bose magnetron. So here it is logical to say that it is low spin complex, because 2 possibility of magnetic moments are there: high spin and low spin. If it is weak, if it is not Cn, some other is there, then the number of unpaired electrons will be but here now there is no unpaired electrons, so that's why we are using the word low spin complex. And this is inner orbital complex. Inner means in hybridization we are writing D2sp3. Moving to K3FeCN6, FeCN6 3 minus, iron is present in +3 oxidation state. So I can write 3D54S0. Again here, since the charge number is increasing, oxidation number of iron is increasing, and this is a strong field ligand, so definitely delta naught is greater than pairing energy. If delta naught is greater than pairing energy, means we can write the electronic configuration over here. So why we are writing like this? There is a logic behind that, and the logic is crystal field theory. So we know that delta naught is greater than, then we'll fill 1 electron, and then pairing will take place here only, right? Right. So here we are writing like this. Logic is same. If there are 5 electrons and strong field ligand is there, one will fill 1 electron, and then pairing will take place. One unpaired electron will be there. So the substance is paramagnetic because unpaired electron is there, and magnetic moment is √3, that is equal to 1.732. So here in case of this strong field ligand, there is formation of inner orbital complex. Moving to the fifth option, cobalt NS3 6 times 3 plus. So here the coordination number is 6. Cobalt in +3 has electronic configuration of 3D6 4s2 because cobalt is 3D7 4s2. If you remove 3 electrons, it is 3D6 4s0. Now ammonia is a strong field ligand and cobalt is present in +3. With cobalt we are saying that when cobalt is present in +3 and up to fluorine it is weak field ligand. After fluorine they are a strong field ligand. So meaning is that delta naught should be greater than pairing energy. Means if delta naught is greater than pairing energy and 6 electrons are there, will pair these electrons, and there is formation of inner d orbital complex or low spin complex. We can say magnetic moment will be 0. So why we are pairing? The logic is again CFT, right? 6 electrons are there, delta naught is greater than pairing energy. So 6 electrons will come here, and these 2 orbitals are vacant, and these orbitals we know that in D2sp3 hybridization, the 2 d orbitals which are involved is dx square y square and dz square. These are known as axial orbitals. Okay, so moving to the next example, NiNS3 6 2 plus. So we know that when nickel is present in +2 oxidation state, the electronic configuration of nickel is 3d8. If the electronic configuration of nickel is 3d8, either it is weak field ligand or a strong field ligand in octahedral complex, electronic configuration will remain same because this will filled completely by 6 electrons and 1 electron will go here, right? So either it is weak field ligand or a strong field ligand, this is not going to change. The number of unpaired electrons are not going to change. So sometimes they will say that we have discussed a point that in case of nickel, it is not always necessary that if it is a strong field ligand, then there is inner orbital complex. So those points we'll see in examples. Like here nickel +2 ammonia is a strong field ligand, but again here you can see that there are 8 electrons. So if we fill the electrons here, there are 2 unpaired electrons, and we cannot send these 2 electrons. If I send this electron here, there is no benefit. We need 2 vacant d orbitals of 3d2 if we want to make inner orbital complex. Here if I pair also, there is no benefit. And why I should pair? There is no logic behind it because it is explained by CFT, right? So this will be there, and now we have to dependent on outer atomic orbital d orbital to have the hybridization sp3d2. So मैं कह सकता हूं कि outer orbital complex बनेगा, और इसमें इलेक्ट्रॉनिक कॉन्फ़िगरेशन D8 में कोई नहीं है लो स्पिन और हाई स्पिन का मतलब, क्योंकि अगर 8 इलेक्ट्रॉन्स हैं, अगर वीक फील्ड लिगेंड होगा तो भी 2 अनपेयर्ड इलेक्ट्रॉन होंगे, स्ट्रॉन्ग फील्ड लिगेंड होगा तो भी 2 अनपेयर्ड इलेक्ट्रॉन होंगे. देयर इज नो मीनिंग, राइट? तो अगर मेरे पास 2 अनपेयर्ड इलेक्ट्रॉन्स हैं तो मैग्नेटिक मोमेंट में लिख सकता हूं 2 प्लस सम वैल्यू अप्रोक्सीमेटली 0.7 और 0.8. तो 2.7 और 2.8 is the magnetic moment. Again, this is a complex of nickel +2, but water is a weak field ligand. Water is there. In this case also, either it is weak field ligand or a strong field ligand. This configuration is fixed. So outer orbital complex will be formed and number of unpaired electrons will be 2 only, right? So here In case of nickel 2 plus, water and ammonia cannot distinguish that it is weak field or strong field ligand. But there is a difference in the crystal field splitting energy. Crystal field splitting energy of nickel NH3 6 times 2 plus will be more than crystal field splitting energy of nickel H2O 6 times 2 plus, because of the effect of the ligand. The next example is NiCO4, and this NiCO4 nickel is present in zero oxidation state. So crystal field theory is not going to valid, because in crystal field theory the central atom is positively charged and the ligand is negatively charged. If the ligand is not negatively charged, at least the ligand is polar, right? So the negative and positive part of the central atom will come and form ionic bond like that. So when we are discussing here NiCO4, in NiCO4, CFT is not valid, right? So, and CO is a strong field ligand, and we have written that the electronic configuration of the nickel in zero oxidation is 3d8 and 4s2. Now we know that coordination number is 4, so there are two possibilities. Either the electronic configuration will be sp3 or dsp2. So when we are discussing here the electronic configuration, because this is a strong field ligand and we have to vacate this s orbital, and we have written a point that in presence of a strong field ligand, two electrons can move, a pair of electrons can move from higher energy orbital to lower energy orbital. That's why these two s or atomic electrons will move inside. So this will be 3d10 and 4s. So now s 1s 4s and 4p atomic orbitals will combine and they will mix to form hybrid orbitals. So sp3 hybridization, right? And it has tetrahedral geometry. All electrons are paired, so magnetic moment will be zero. We cannot explain the magnetic moment with the help of crystal field theory. It is not valid. NiCN4 2 minus, here also nickel is present in +2 oxidation state. So electronic configuration is this, but here coordination number is 4 and Cn is a strong field ligand. So what will happen in case of a strong field ligand, whatever the 8 electrons are there will pair these electrons, and by pairing these electrons, one d orbitals will be vacant. So we can say that hybridization will be dsp2. So that can be possible because Cn is a strong field ligand, and if we want one vacant d orbital, that can be vacant. So hybridization will be dsp2. Now the logic that why we are doing like this can be explained by crystal field theory. In case of crystal field theory, this is the order of energy. So we have 8 electrons. So when we fill 4 electrons here, 2 electrons here, and 2 electrons here, so this atomic orbital will be vacant for hybridization, and this is dx square y square. So they can ask that which atomic orbitals will participate in dsp2 hybridization when the geometry is square planar. So moving to the 10th example, COCO4. Again, this is carbonyl compound, and CFT will not be valid here. So electronic configuration of cobalt is 3d7 4s2, and here this is a strong field ligand, so 2 electrons can move, so it will become 3d9. When it will become 3d9, because in both cases I have to make empty this s orbital, right? So only possibility, because either dsp2 hybridization or sp3 hybridization, we have to make vacant the s orbital. That's why we are doing that. We are, because in presence of a strong field ligand, a pair of electrons can move from higher energy level to lower energy level. So by doing that, we are getting 3d9. So all the d orbitals are occupied, and magnetic moment will be 1.7 Bohr's magnetone, 1.732 Bohr's magnetone, and hybridization will be sp3. It is tetrahedral. So here also CFT is not valid. 11th example, MnCl4 2 minus. Manganese here is present in +2 oxidation state. Electronic configuration of manganese is 3d5 4s2. So manganese +2 3d5. So this 4s atomic orbital is vacant, and Cl is a weak field ligand. Coordination number is 4. So when coordination number is 4, Cl is a weak field ligand. So chances of this is that it will form tetrahedral, because pairing will not take place, and there are 5 unpaired electrons over here. So hybridization will be sp3. If it is sp3 hybridization, now by CF2 we can explain this, that we have 5 electrons. So we'll fill 1 electron in each, because in case of tetrahedral complex, the crystal field splitting energy delta T is less than pairing energy. So we'll fill 1 electron in each, and then pairing will take place. Next example is of copper. Copper here CuNH3 4 times, and this is copper 2 plus, and we know that this is a colored compound, deep color compound is there, and it has square planar geometry. We are going to explain that how. So copper is present in +2 oxidation state. So electronic configuration of copper is 3d10 4s1. If we remove 2 electrons, then it will be 3d9 4s0. So there are 9 electrons here, but we have written that ammonia is a strong field ligand. In presence of a strong field ligand, 1 electron can move from its lower energy atomic orbital to higher energy atomic orbital. So here what is happening, that this 1 electron from here is moving to 4p atomic orbital. So hybridization is dsp2, and this is a square planar geometry. So experimentally we got this geometry, and then we are trying to explain that how it is going to take place. Right, 9 electrons, how we can say that it is happening, that it has a square planar geometry? That is the way to explain. So a single electron can shift in higher energy orbitals in presence of a strong field ligand. This is the most important point. Next example is CuNH3 twice Cl2. So here 2 strong field ligand and 2 weak field ligands are there, and the same way we are writing that copper is present in +2 oxidation state, and electronic configuration is 3d9 and 4s0. Again we are applying the same concept, but by theory we can't say directly, right? 2 strong field and 2 weak field ligands are there. Sometimes 1 strong field and 3 weak field ligands can also be possible, but in this case, when 2 strong field ligands are there, then delta is greater than pairing energy. When delta is greater than pairing energy, it means that we have to explain that how this molecule is a square planar, right? So there is only one way, what we have explained in copper +2 and NH3 4 times. So these two examples are of similar type, where the electron is moving from one atomic orbital, inner atomic orbital, to outer atomic orbital in presence of a strong field ligand. Here not only strong, here it's strong as well as weak is there, but I think that the domination of strong is more than that of weak. The effect of ammonia is more than that of weak. So delta naught value is fulfilling this criteria, and because of that this is happening. So these two examples are important one. Now K3CuCN4. So here copper is present in +1 oxidation state. If copper is present in +1 oxidation state, electronic configuration will be 3d10 4s0. So now we cannot send these 2 electrons, because Cn is a strong field ligand. So we cannot send 2 electrons from a pair of electron. Now a single electron we can send. So that's why hybridization will be sp3. It has tetrahedral, magnetic moment will be 0. FeCO5. Again FeCO5 is a metal carbonyl, right? And CFT is not valid for such compounds where the central metal atom, and it is carbonyl, and metal atom is in 0 oxidation state. So here we can write the electronic configuration of iron 3d6 4s2. Whatever the hybridization, we have to make vacant this s orbital, right? We have to vacant this s orbital. Now the logic will say that CO is a strong field ligand. In presence of a strong field ligand, 2 electrons can move from higher orbit to inner orbit. So what will do that? Will fill 8 electrons over here, and this d orbital is vacant. So hybridization is dsp3. Now in this dsp3, the geometry will depend that which type of d orbital is participating in hybridization, right? So here dz hybrid orbital, dz d orbital, dz square d orbital is participating in hybridization, and because of that the geometry of this complex is trigonal bipyramidal. If geometry is trigonal bipyramidal, that will be supported by this dz square atomic orbital, because it along the z direction, and this sp. So the geometry is trigonal bipyramidal geometry, pair of electrons can shift in lower energy orbital in presence of a strong field ligand. So this is coming again and again. 16th example, K3COC2O4 thrice. So in this case, you can see that cobalt is present in +3 oxidation state, and in NCERT they have mentioned that up to F minus they will act like weak field ligand. So oxalate ion or water will a strong field ligand for cobalt +3. So delta naught is greater than pairing energy. 3d6 electronic configuration will be there and all electrons will be paired. So inner orbital complex will be formed. Magnetic moment will be 0. So here there is a meaning to say low spin complex, because suppose this pairing is not taking place, then we can fill 5 electrons and then pairing will take place. So the number of unpaired electrons will be 4, but now here it is 0. So we can say here that, okay, it is a low spin complex. It is an inner orbital complex. Another example is KAuCl4. We know that gold is a metal atom of 5D series. And in case of 5D series, we know that the crystal field splitting energy will be more as we move down the series. So because of that, Cl is a weak field ligand, but because of this gold, delta value will be greater than pairing energy, and we can say that copper, silver, gold has electronic configuration. We know 3d10, 4s, n-1d10, and ns1. So here gold is present in +3 oxidation state. So electronic configuration of gold +3 will be 3d8, 4s, 0. There is removal of 1 electron from 6s, 0. There is removal of 1 electron from 6s atomic orbital and 2 electrons from 5d. So 8 electrons are there, and we are saying that in this is of 5d, so weak field ligand will behave like a strong field ligand, so pairing will take place, and there are 4. So there are possibility of sp3 and dsp2. Since it is behaving like a strong field, there is vacant d orbital, so hybridization will be dsp2. Magnetic moment will be 0. So again, this is very important, where the type of transition metal participating in forming the complex is playing an important role, that pairing will take place or not, or what will be the hybridization. The next example is FeH2O 5 times NoSO4. So here NO, if I take NO as +1, this is neutral. So iron is present here in +1 oxidation state, because let me check here. This sulfate ion is there, so this coordination complex has +2 charges. If NO is present as NO+, then iron is present in +1 oxidation state. So brown ring test में ये compound होता है. So what we are discussing here, iron +1 electronic configuration is 3d6 4s1, right? In 3d6 4s1, what is happening, that this strong field ligand is there. NO is a strong field ligand. So one single electron can move from higher energy orbital to lower, because we have to make vacant this, either whatever the hybridization S तो उसमें होगा, तो इसको ये हमें खाली करना होगा. So 3d7, when we are filling these electrons, what we are doing that, since these are 5 weak field ligand, right? So 1 electron तो यहाँ पे आ गया, but when we are filling the electrons, crystal field splitting energy is less than mean pairing energy. Delta naught is less than mean pairing energy. Because of that, we are filling 1 electron here, and then pairing is taking place. So the number of unpaired electrons will be 3.7. And hybridization is sp3d2. It is outer orbital complex, because 6 में से 5 ligand जो हैं वो वीक फील्ड लिगेंड है, तो वीक फील्ड लिगेंड का पोर्शन जो है वो ज्यादा डोमिनेटिंग है, और आयरन का ऑक्सीडेशन स्टेट भी कम है. When we are discussing about this another compound used in nitroprusside test, so here also NO is present in NO plus and Cn minus here, right? So if I see here, the charge on this complex ion is -2, और यहाँ -5 और +1 means -4. So iron is present in +2 oxidation state. So I can write the electronic configuration as 3d6 4s0, and these are strong field ligands, so pairing will take place. So it will form inner orbital complex or low spin complex, because अगर ये पेयरिंग नहीं होती तो अनपेड इलेक्ट्रॉन्स 6 इलेक्ट्रॉन है तो 4 होते उस केस में आउटर, बट हियर पेयरिंग इज टेकिंग प्लेस, सो इट इज लो स्पिन कॉम्प्लेक्स. Another important example, this complex compound exists in two forms, cisplatin and transplatin, but cis cisplatin is very important because it is used in chemotherapy, used in cancer treatment. So PTNS3 twice Cl2, दो वीक फील्ड है और दो स्ट्रॉन्ग फील्ड है, लेकिन आई थिंक हियर द स्ट्रॉन्ग फील्ड नेचर इज डोमिनेटिंग. सो निकल पैलेडियम प्लैटिनम, द रीजन इज दैट ये दो तो हैं लेकिन ये 5D सीरीज का है. इफ इट इज ऑफ 5D सीरीज then definitely delta value will be greater than pairing energy, and because of that we can write the electronic configuration as dsp2, क्योंकि 8 इलेक्ट्रॉन है और ये सारे पेयर्ड होंगे, और जब सारे पेयर्ड होंगे तो एक d ऑर्बिटल खाली होगा एंड हाइब्रिडाइजेशन विल बी dsp2. CFT से समझें इसको तो 8 इलेक्ट्रॉन जो है इसको हम CFT से समझ सकते हैं. 8 इलेक्ट्रॉन्स if we will 2 4 electrons here, 6 and 8, so one vacant d orbital is there. So this is about cisplatin or the complex PTNS3 twice Cl2. Now let us solve some examples so that we can revise whatever we have learned. So these are very simple examples. Let us go one by one. So match column is there. The first one is cobalt is plus present in +3 and En is a strong field ligand. So if I have to solve this cobalt +3 का मतलब हो गया cobalt का electronic configuration will be 3d6 and strong field ligand है. तो अगर मुझे लिखना है 6 इलेक्ट्रॉन है, strong field ligand है, तो there will be pairing. If there will be pairing then there is no unpaired electrons and दो d orbitals खाली हो गए, तो मैं कहूंगा inner d orbital complex form हो रहा है D2sp3, and in this D2sp3 this is diamagnetic also. So if I try to match that, what is the matching? So hybridization is D2sp3 and the substance is diamagnetic. Chelating एजेंट का मतलब है कि अगर कोई चेन फॉर्म कर रहा हो, बाइडेंटेट ट्राइडेंटेट लिगेंड्स कैन फॉर्म रिंग. So definitely ethylene diamine is a bidentate ligand. So because of that we are saying coordination number is 6. So chelating agent, yes, this is chelating agent, so this is also correct. Let us move for the next option. B option को देखते हैं. B option में है cobalt अगेन +3, और ये तो एनसीईआरटी में एग्जांपल है, ये ऑक्सलेट C2O4 2- आयन, राइट, ऑक्सलेटो. सो coordination number is 6. Again cobalt is present in +3 and it is behaving like a strong field ligand, so we can say that electronic configuration will be 3d6. I can directly write that inner d orbital complex will form, D2sp3 will form. And since it is bidentate ligand, it is also participating in chelation, so I can say that same options will be there. For A, Q, R and T was the answer, Q, R and T. For B also the answer will be Q, R and T. Moving to the C option, in case of cobalt, but here cobalt is not +3, cobalt +2 is there, and water is a weak field ligand. So if I am discussing this, cobalt +2 is there and water in case of cobalt +2 will behave like weak field ligand. अगर यहाँ +3 होता तो strong field ligand होता. Now cobalt in +2 has electronic configuration of 3d7. So 3d7 है, weak field ligand है, so d orbital खाली नहीं होगा. If we fill the electrons, will fill 1 electron in 3d, तो ये 5 हो गए, और then pairing will take place. So 7. So number of unpaired electrons are 3. The substance will be paramagnetic, no doubt, and it will form outer orbital complex sp3d2. So if I try to match this C option, COH2O 6 times, it has sp3d2 electronic configuration, so P will come. It is paramagnetic, S will come. It is not monodentate ligand, so it is not a chelating agent, right? So P and S should be the matching. Again, for the D option, cobalt is present in +2 oxidation state, but NO2 is a strong field ligand, right? So in this, I can say that 3d7 electronic configuration will be there, but NO2 is a strong field ligand. So in presence of a strong field ligand, we can say that pairing will take place. So 7 electrons है, pairing हो गई. Coordination number कितना है इसका? 6 है. So let me write this. Coordination number अगर इसका 6 है, strong field ligand की प्रेजेंस में एक इलेक्ट्रॉन लोअर एटॉमिक ऑर्बिटल से हायर एटॉमिक ऑर्बिटल में जा सकता है। तो इस हिसाब से ये एक डी ऑर्बिटल दो खाली हो गए, एक एस ऑर्बिटल और 3 पी ऑर्बिटल खाली हो गए। हाइब्रिडाइजेशन होना चाहिए इसका D2sp3, दिस शुड बी D2sp3। और एक इलेक्ट्रॉन जो होगा वो 5D में होगा। दिस इलेक्ट्रॉन, सिंगल इलेक्ट्रॉन कैन मूव फ्रॉम lower atomic orbital to higher atomic orbital in presence of strong field ligand. So we are using that concept. So because of that, I can say that there is formation of the substance is paramagnetic. So S option will come, inner orbital complex will form, and this is a monodentate ligand, so there is no chelation at all. So the answer of A is QRT, the answer of B is QRT, the answer of C is PS, and the answer of D is RS. Again here column 1, column 2, and we have to do this. There is an information written here already. We know that when the electronic configuration is D4, D5, D6 and D7, then there are two possibility. If pairing will take place, then we'll say that it will low spin complex, and if crystal field splitting energy is less than pairing energy, then pairing will not take place, and we'll say that it is high spin complex. So D4, D5, D6 and D7, there is a chances of high spin and low spin, but there is no meaning of high spin and low spin when electronic configuration is D1, D2, D3 or D8, D9, D10. There is no meaning at all, right? So only on 4 cases there is a meaning of low spin complex and high spin complex. So that is mentioned here. Now we are going to solve the first option, MnCN6 3-. So in the first option, this manganese is present in +3 oxidation state, and Cn is a strong field ligand. Cn is a strong, Cn- is a strong field ligand. So keeping that in mind, manganese electronic configuration, I can write manganese has an electronic configuration of 3d5 4s2. Now I have to remove 3 electrons. So in case of Mn+3, the electronic configuration will be 3d4 and 4s0. This is the electronic configuration. Coordination number is 6 and 4 electrons are there. So I will pair them, and while pairing we should understand logically that ki CFT के हिसाब से नीचे 3 atomic orbitals हैं, right? In CFT there are 3 atomic orbitals. That is these atomic orbitals are T2G and this is EG, right? So पहले T2G में हम इलेक्ट्रॉन भरते हैं, एक एक इलेक्ट्रॉन भरेंगे, 4 इलेक्ट्रॉन, और फिर पेयरिंग होगी. So that should be exist like this. इस तरह से एग्जिस्ट करना चाहिए. और फिर ये 2 एटॉमिक ऑर्बिटल्स जो हैं वो वैकेंट है. तो ऐसा नहीं है कि अगर स्ट्रॉन्ग फील्ड लिगेंड है तो बिना सोचे ही आप सबको पेयर्ड कर दो. दिस इज रॉन्ग, राइट? वी हैव टू थिंक अबाउट CF2, एंड CFT के हिसाब से ये T2G और EG, और स्ट्रॉन्ग फील्ड है तो गैप ज्यादा है, तो पहले हम इसमें इलेक्ट्रॉन फिल करेंगे. 4 इलेक्ट्रॉन्स हैं तो इसी तरह से फिल कर सकते हैं. सो दिस सब्सटेंस इज पैरामैग्नेटिक. कुछ बच्चे स्ट्रॉन्ग फील्ड देख के गलत कर सकते हैं. दे कैन पेयर दिस इलेक्ट्रॉन इज these 2 electrons also, which is wrong. So now I can say that the hybridization is D2sp3 and substance is paramagnetic, and there is of course inner orbital complex is forming. Inner orbital complex, there is no denying that. But if 4 electrons are there, now you have to think that कि ये low spin कहलाएगा या नहीं कहलाएगा. Yes, 4 electrons है, ये low spin कहलाएगा. वरना अगर ये स्ट्रॉन्ग फील्ड लिगेंड नहीं होता, सब में एक एक इलेक्ट्रॉन भरते, तो वी कैन से लो स्पिन कॉम्प्लेक्स. तो ट्राई टू मैच दिस. पहले का आंसर, सब्सटेंस इज पैरामैग्नेटिक. डेफिनेटली द सब्सटेंस इज पैरामैग्नेटिक, व्हिच इज इंपॉर्टेंट. सम ऑफ यू विल डू रॉन्ग. देन इट इज इनर ऑर्बिटल कॉम्प्लेक्स, देन इट हैज लो स्पिन कॉम्प्लेक्स. यस, PRT शुड बी द आंसर. मूविंग टू द बी ऑप्शन. अभी हमने सॉल्व किया था कोबाल्ट +3 के लिए. For cobalt +3, what oxalate ion is a strong field ligand. C2O4 2- will act like a strong field ligand. If it is acting like a strong field ligand, then pairing will take place, right? 3d6 electronic configuration will be there. So I can directly write that all the electrons are paired. So, and there is formation of inner orbital complex. Let me draw here that 6 electrons are there. तो अंदर के जो 2 d orbitals हैं वो खाली हैं. They will participate in bonding. So I can say that for C2O4 thrice 3 minus, substance is diamagnetic, Q option correct है. Inner orbital complex form हो रहा है, ये भी correct है. Low spin complex है, that is also correct, right? So QRT will come, that is fine. Now moving to the C option, अभी हमने डिस्कस किया था कि कोबाल्ट अगर +3 ऑक्सीडेशन स्टेट में है लेकिन फ्लोरीन जो है वो वीक फील्ड लिगेंड की तरह बिहेव करेगा. So if it is behaving like weak field ligand, electronic configuration is 3d6. So what we'll do, we'll put 1 electron and then pairing will take place, right? तो 5 electrons पहले रखेंगे और फिर pairing होगी. Because here we are saying delta naught is less than crystal field splitting energy, so we'll fill all the atomic orbitals by single electron and then pairing will take place. So unpaired electrons will be 4. So it is a paramagnetic substance and definitely outer d orbital use hoga. So in case of COF6 minus, we'll say that the substance is paramagnetic. P option will come. And this is outer orbital complex, and this is not low spin. This is definitely high spin complex, not low spin complex. The last option is about Mn +3, right? MnCl6 3 minus. So manganese is present in +3 oxidation state, but chlorine Cl minus is a weak field ligand. Weak field ligand. So if I write electronic configuration 3d5 4s2 for manganese atom, now for manganese 2 plus there is loss of 3 electrons. So 3d4 4s0. So 4 electrons are there in 3d atomic orbital. So if I fill these electrons and coordination number is 6, right? तो आप जरा CF2 को ध्यान में रखें, ऐसा नहीं कि वीक फील्ड लिगेंड है तो सब में है ना, पहले हम 3 इलेक्ट्रॉन्स भरेंगे नीचे वाले में, because yeah, okay, so here I am saying that delta naught is less than pairing energy, तो सब में पहले एक एक इलेक्ट्रॉन भरेंगे. We are going to fill 1 electron in each and then pairing will 4 ही इलेक्ट्रॉन भरने हमें, so we'll fill 1 electron in each. Will fill like this. So the number of unpaired electron will be 4. The substance is paramagnetic. And in this case, I cannot use this inner d orbital because ये weak field ligand है, एक इलेक्ट्रॉन यहाँ से या pairing हो नहीं रही है. I can't use this d orbital. So I have to write that the hybridization should be sp3d2. I have to use the outermost d atomic orbital, right? So now I can write that the substance is paramagnetic. That is correct. Outer orbital complex is forming. That is also correct. And it is high spin complex. It is not low spin complex. 4 electrons may possibilities are there. That number of unpaired electron, all the 4 are unpaired or 2 are unpaired. So here all the 4. So high spin complex will be there. It is not low spin complex. So I think that the answer of this question should be A का होना चाहिए PRT, B का QRT, and C का PS and D का PS. So this is not a question. This is just a conclusion which when we are discussing about the hybridization, what are the points which we can conclude here. जैसे DSP2 हाइब्रिडाइजेशन जब कोऑर्डिनेशन नंबर 4 होता है तो या तो हाइब्रिडाइजेशन जो होगा वो DSP2 होगा या हाइब्रिडाइजेशन जो होगा वो sp3 होगा. इन केस ऑफ sp3 एंड DSP2 में ये पूछा जाता है कि कौन सा d एटॉमिक ऑर्बिटल पार्टिसिपेट कर रहा है. So that is dx square y square and the geometry is square planar. Same way, when we are discussing about octahedral complex, either it is inner octahedral complex or outer atomic orbital complex, right? दो d orbitals use हो रहे हैं. Which d orbital it is? They are axial orbital, dx square y square and dz square. Similarly, we can say that in sp3d and dsp3. So these things are there, like in NCERT there is an example of FeCO5. बाकी examples तो नहीं, लेकिन ये example तो NCERT में दे रखा है. This is given in NCERT, right? So with the help of this we should understand that. और इसका हमें geometry भी पता है, trigonal bipyramidal geometry है इसका. So if we write electronic configuration and all that, we got that the hybridization because it is a strong field ligand. Iron जो है वो 3d6 है, 0 में प्रेजेंट है, 4s2 है, 2 इलेक्ट्रॉन अंदर चले जाएंगे. वी कैन राइट 3d8 4s0, राइट. अब हमें एक d ऑर्बिटल खाली मिल रहा है क्योंकि ये 4 है और ये स्ट्रॉन्ग फील्ड लिगेंड है. तो आई शुड राइट दैट द हाइब्रिडाइजेशन विल बी dsp3, this dsp3. But by theory I can't say that which d orbital it is because this d orbital will depend on geometry. तो अगर ज्योमेट्री ट्रायगोनल बाई पिरामिडल होगी तो जो डी ऑर्बिटल होगा वो होगा dz स्क्वायर। वही समझाया है यहाँ पे कि अगर ज्योमेट्री ट्रायगोनल बाई पिरामिडल है then this will be dz square, because here there is an example like FeCO5 तो मैंने डिस्कस कर दिया, but you can see two examples, these are important. कॉपर जो है यहाँ +2 ऑक्सीडेशन स्टेट में, कॉपर एंड Cl- इज अ वीक फील्ड लिगेंड, सो 3d9 4s 0, राइट, बिकॉज 3d10 4s1 में से 2 इलेक्ट्रॉन चले गए। नाउ यहाँ पे 9 इलेक्ट्रॉन है, ये वीक फील्ड लिगेंड है, तो मैं इसको तो खाली कर नहीं सकता, cannot use the inner d orbital and coordination number is 5, so I have to write sp3d. अब इसमें कौन सा d orbital participate कर रहा है, that will depend on geometry. So from experiment we got that this is trigonal bipyramidal, then we can say that dz square atomic orbital is participating in hybridization. सेम वे निकल +2 में यहाँ पे एग्जिस्ट कर रहा है, इलेक्ट्रॉनिक कॉन्फ़िगरेशन निकल का होगा 3d8, निकल +2 का 3d8 4s0। तो अभी ये स्ट्रॉन्ग फील्ड लिगेंड है, स्ट्रॉन्ग फील्ड लिगेंड में आई कैन पेयर द इलेक्ट्रॉन्स ना, एक एटॉमिक ऑर्बिटल में खाली करा सकता हूँ। In presence of this I will make this vacant, so what is happening, dsp3 hybridization is there. Now ये d कौन सा है ये डिपेंड करेगा व्हाट इज द ज्योमेट्री। तो ज्योमेट्री अगर ये है तो डेफिनेटली डी ऑर्बिटल होगा dx स्क्वायर y स्क्वायर, दिस इज नोन एज स्क्वायर पिरामिडल ज्योमेट्री, राइट। अगर यहाँ पे ज्योमेट्री होती ट्रायगोनल बाई पिरामिडल तो ये जो डी ऑर्बिटल होता वो dz स्क्वायर होता। So the chances of these two are less, but because FeCO5 is given in NCERT, and in NCERT they have drawn the structure also, so you should not miss if they are asking that which type of d atomic orbital is participating in hybridization. I want to add one more point here about the hybridization of MnO4 minus, right? ये भी है हमारे NCERT में, या हम डिस्कस करें CrO4 2 माइनस। तो इसमें जो मैंगनीज है इसका ऑक्सीडेशन स्टेट +7 है, यहाँ क्रोमियम जो है वो +6 में प्रेजेंट है, वेरी हाई ऑक्सीडेशन नंबर आर देयर, राइट। सो मैंगनीज का इलेक्ट्रॉनिक कॉन्फ़िगरेशन होता है 3d5 4s2, तो ना तो 3d में कोई एटॉमिक ऑर्बिटल इलेक्ट्रॉन्स है ना 4s में कोई इलेक्ट्रॉन्स है, राइट। तो इसका 3d खाली है, और इस वजह से वी आर सेइंग दैट इट्स हाइब्रिडाइजेशन इज d3s। So ये थोड़ा complicated है, but it has d3s hybridization. Same way I can say for chromium, chromium +6 का मतलब हो गया 3d पूरा खाली, because 3d5 4s1 होता है, 6 इलेक्ट्रॉन सारे गायब है यहाँ से, और ये हो गया 4s0. So again I will say that the hybridization of this is d3s. Though d3s hybridization is not in our syllabus, but in NCERT they have given the geometry of this. We already know in D block that MnO4 minus का अगर मैं structure draw करता हूँ तो it has tetrahedral structure, and because of resonance all the manganese oxygen bonds are equivalent. तो ये tetrahedral geometry है। Same way अगर मैं chromium chromate ion के लिए draw करता हूँ, so for chromate ion also we are going to get the same thing. So we can draw here double bond O, double bond O, O minus and O minus, and again because of resonance all the bond lengths are equal, right? Chromium oxygen bond length are equal. So ये पूछा तो नहीं जाएगा, but you should know that this is tetrahedral and this is also tetrahedral and this is d3s hybridization. तो मैं ये उम्मीद करता हूँ कि मैंने कुछ आपकी मदद करी है हाइब्रिडाइजेशन को लेके, और बहुत सारे क्वेश्चंस जो है वो मेंस में आते हैं और जेईई एडवांस में आते हैं कोऑर्डिनेशन कॉम्प्लेक्स के लिए। तो आप वेट करिए पार्ट 5 ऑफ कोऑर्डिनेशन कॉम्प्लेक्स, जिसमें हम आइसोमेरिज्म के बारे में डिस्कस करेंगे, कोऑर्डिनेशन कॉम्प्लेक्स आइसोमेरिज्म। मैं आपसे रिक्वेस्ट करता हूं कि प्लीज हमारे चैनल को लाइक करिए और बहुत सारे बच्चों को बताइए। थैंक यू।